All right, car has an oil leak. Every 5 seconds, an oil drops from the bottom of the car onto the road. What force causes the oil drop to fall towards the road? Okay, this is gravity. Now, what it's not is gravitational potential. Gravitational potential is an energy. It's something we can measure. It's a number, but it's not a force. It doesn't make things happen. So forces make things happen. So the reason things fall to the ground is not because of gravitational potential energy. It's because of the force of gravity, okay? So you could also say the weight, which is just another word. Okay, so the car starts here, and then gradually you can see the oil drops get more spaced apart. So describe the motion. The car is accelerating. Give a reason for your answer. Two points to make. The first one is distance between spots is increasing. You've got to mention that it's getting bigger. Okay? It's not enough to say, by the way, the distance between the spots is bigger. Okay? You've got to say it's increasing. That means that it starts off short and then it ends up bigger. You've got to say that you've got to give the sense of changing. So, therefore, more distance in equal time. So, remember what it says. It says every 5 seconds. So that means the time between each of these dots is the same, right? You've got to make that last point. Okay, that's the only bit. Most people missed that third point because you didn't quite tell the whole story. Yeah, accelerating. Yes, it's accelerating. The distance between the spots is increasing, but it could be increasing because the oil drops are getting less frequent. You see, they could be getting less frequent, but we know that that's not true because it says that it's every 5 seconds. So you have to say we know that they're 5 seconds apart and the distance is bigger each time, right? So therefore, speed is greater. Good. When the brakes are applied, a braking force slows down and stops the car. The size of the braking force affects the braking distance. State one other factor that affects the braking distance of the car. Okay, so what you could have here, the most important one is speed. So that's a good one to have. Other ones you can have condition of road or tyres. How do you spell tyres? It's Y, isn't it? Tyres, speed, condition of road or tyres. Either of those two things is fine. Now, one thing that you can't talk about is thinking time. Now, have a think. Why is this not the answer? Well, look, the braking distance. Okay, the braking distance is the distance you travel while braking. Okay, remember what the stopping distance overall. Stopping distance is thinking plus braking distance for both. All right, it's asking us about the braking distance. Okay, so this is after you've put your foot on the brake. How long does it take, or how far do you travel before you stop? So thinking time does not come into the braking distance, okay? The thinking distance is how far you travel before you put your foot on the brake, okay? So try not to get those things mixed up. It's very easy to do that, but it's obviously not correct for you to talk about the thinking distance in this case here. Okay, how over time? Okay. A braking force of 3 kilonewtons is used to slow down and stop the car in a distance of 25 metres. Calculate the work done by the brakes to stop the car and give the unit. Okay, so work done is force times distance. Work done equals force times distance. Now, the thing that people forgot is Look, killer. So this is 3,000 newtons, all right? So if the work done is going to be in joules, then the force needs to be in newtons and the distance needs to be in meters. So 3,000 times by 25 meters is 75,000 joules. Whoops, let's just put the unit in here. Now, a few people wrote down the answer here as 75,000 Newton meters. Now, that's fine. That's fine. Newton meters and joules, these are equivalent to each other, right? Right? They are equivalent to each other. But if you're talking about work done, then you're talking about energy being transferred. And so the joules are the units for energy. So even though these things are equivalent, it's more correct to use joules. Okay, so I gave you the mark for Newton meters because we know it's correct, but it wasn't on the mark scheme. Okay, so just to be safe, if you're talking about work done, then always do it for joules. Okay, we're on to the last question. How long have we got? About 4 minutes. Okay, so we've got the experiment to do with Boyle's law. Give 2 reasons why taking repeat readings could provide more accurate data. I'm not going to make a big song and dance about this because you should know it, although some of you still did not write it down. It is to reduce the effect of random errors. Some of you are still not writing this down. I don't know what I'm going to have to do. I've said it 1,000 times. I don't know what I have to do. Please, please, please remember that. Why do you take repeat readings? To reduce the effect of random errors. Why else? To spot anomalies. The final one you can have. To calculate a mean. Okay, either of those is fine. Please don't forget this one, that top one, because that's the most correct. Okay, here we've got a parallax error. Okay, remember, you've got, if your eye's up here, you look at the meniscus, your value is too low. It's called a parallax error, and it is a random error. Random error. And why is it a random error? What were they looking for again? Yeah. Because eye position would be different each time. Okay. Now, you could, because some people call this a systematic error, but it's only a systematic error if you're looking from the same position every time. So if you're always looking at it from a too high a spot, then all of your results are going to be too low. And so that would be systematic. But you had to be very clear of saying that if you were to get the mark for saying it's systematic. Okay, if you write down it's a random error, then you will get the mark, because this kind of error, really, this thing is a random error. It's going to be different each time. Okay, so please in future just refer to that as a random error. Please do not refer to it as a human error, because human errors do not exist in GCSE. Okay, you've got random errors, you've got systematic errors, and then you have to describe what they actually are. Human error is never enough. Okay, so please get that out of your toolkit of writing down random error. Okay, how long have we got? Okay, we're just out of time. I'll just do the next video, will be a short one just to finish off.